Hello and welcome to today's lecture on DevOps. I'm Prasanjit Singh and I will be taking you through DevOps tools and practices. So today we will discuss about the practices which are done as a DevOps engineer, and in order to do those practices, apply those practices, what are the tools that are used and how to set up your ecosystem for working in this DevOps environment. Like you will have to set up your workbench, the different tools that you use, the text editors that you use, virtual machines, and so on. I'll tell you, and I'll also give you a bit of idea on how to install Linux, because any server you would work at any company would mostly, like 98%, it would be having a Linux operating system. That's what has happened in my career of around 15 years. Maybe 2 times or 3 times I have faced, I have worked with a Windows database or something deployed on a Windows system. There are companies like certain banks and all, they use Windows, but most of the IT companies now are hosted on the cloud and everything is Linux, because there are certain advantages, it's secure and all. That's another story. So let's get started. So today's agenda here would be first to understand what continuous feedback is. Last time in the DevOps introduction session, we had discussed how the DevOps infinite loop works. Remember, there was a phase where you plan, then you build it, then you deploy it, then you test it. If it passes, you release it, then deploy it, and then get the feedback at each stage. Like if your build fails, the developer gets an alert on his channel or mail that this has failed, and using that information he tries to check what has failed and fix it. So if it fails in the testing phase, then they check what test cases failed. If it fails in the deployment stage, like while putting it on the server, then they check what kind of failure happened during deployment. So the operations team will check there, and so on. So that method is called a continuous feedback. So we'll learn about that. Just revisit that. Why? Because we'll understand what tools will be used to implement this system. So that's why this is needed. Then we discuss other DevOps practices at each of these stages, like during each of these phases, when you're taking the code, writing it, putting it into a repository, and then building it and publishing it, and so on. So we'll discuss those practices, and we will then work on, I'll show you how you install Linux, how you set up your laptop or desktop to start working with DevOps, and we'll do those hands-on exercises. So this will, setting up the workbench will be I'll tell you what different softwares we use so that you can download them and start installing in your system. Because in the next session we will have something called version control system. So before that, it would be good to have your laptops ready to work. And then we'll do the hands-on exercises, and since the session is being recorded, then you can revisit the entire thing again and follow what I am doing and do it. And we'll always like in every session, since we have started doing the hands-on exercises, we will towards the end have some time for question answers, so that whatever problems you faced while doing it, I'll just clarify all those problems and move on. Because it would not do justice if I just keep on introducing new concepts and move on with my course, and in the end you are lagging behind. So we'll have some time for clearing the sessions, the questions. All right, so let's discuss the continuous feedback loop. You had seen a similar diagram in the previous slide. Just go through that video again. You would have seen that in DevOps, there are various phases which move on in an infinite loop. First, it was a planning phase where people decide what software is to be built, what different languages are to be used to write that piece of software. We were discussing about an example of a shopping website, and for example, if the developers decided we will write the program of this website using Java language, so then they discuss what are the various kind of other plugins or uh, things that would help to write the code faster and design the websites. They will identify those tools, then they will identify where to deploy that software, how that should be done. All that uh, thing goes into the planning phase. Once the planning is done and they know what to do and how to go about doing it, then it comes to the coding phase, where the developers start writing the code. And in DevOps methodology, they do not write the entire software from A to Z. They do not do that. Like it's not like writing everything from A to Z and then come back and do the testing. So it happens in smaller iterations, just like the agile methodology. But as soon as they save the code and push it into the repository, then when DevOps is implemented, we have certain scripts that trigger off and start building that code. And once the code is built, it creates a archive. Like in case of Java code, it would build a Java archive. These are also called binaries. As I even explained, in case of Windows systems, you might have seen the binaries are called .exe files. So whenever the code is compiled, it makes a binary file. So once that binary is built, that phase is called a build phase. So once the build phase is complete, then it goes on to a testing phase. So that phase uh, takes care of the test cases that has to be run on that new piece of software, and it sees whether all the tests pass. For example, it could test anything, like any feature of the software. For example, in your website, you have a form where the username and password are given, and when you click uh, login, then it should log in. So that test case will try to replicate that same thing. It will automatically put in the username and password and try to log in. If it is able to log in, then the software is working fine. If it is able to log in without a password, then something is wrong. There is no authentication there. If it is working uh, as per the requirements, then the test cases pass and the software moves on to the release phase, and so on. But the thing we are discussing now is, for each of this phase, the success or the failure is immediately reported to the stakeholders. Like for example, if the user starts building the software, then and the build fails. For example, he writes some code and there is a error, syntax error or some bug in the code that is preventing it from getting built into that jar file, and it is throwing some error. In that case, it would immediately take a snap of those errors and mail it or send it on Slack uh, to the stakeholder, for example, the developer or the architects or whoever the team members are. Everyone will get a feedback that your build has failed. Build number was this, initiated by this so and so user, and all the details would be there so that they can immediately start fixing it. Similarly, if the build passes, then they would get alerts like the build has passed and moved on to the next phase, that is the test phase. So in the test phase, the same thing happens. There is continuous testing going on, and then if the test cases pass, then they get an alert. If the test cases fail, they get an alert. So in every stage, you get a feedback, and all this is continuously happening. It's not at the will of the developer, like whenever he wants, he will send the test case alerts, or he would trigger the test cases. So it doesn't happen that way. It's automated. So once you push your code into the repository, it has to go through the entire cycle. So everything is continuous. So how does it work? People collaborate and write code. Why they collaborate and write code? As I said, there could be one piece of software being written by 5 different developers. and all will be collaborating and pushing their code on the same repository. So that is what we'll learn ahead in the next session, like how to do that, like how 5 people are writing a program and sending it to the same repository, how to do that, how Git is implemented. Git is a version control system. So we'll do that collaborative development. Once we move on with that, we will discuss testing, deployment, and so on. So being able to learn this entire cycle is DevOps. So that would finish your course that way. Like if you look at a very high level view, what is DevOps? So learning all these steps and learning how to automate them without human intervention. Like humans will be there, they will write code, but after the code is pushed, next step is automated. Similarly, test cases would be written by some people, but once the test cases is written and saved, those test cases would run on that code and give you a report. So in each step, there is a report that is sent, success or failure, and moves on to the next stage based on that outcome. If it is a failure, then doesn't move ahead, fails there, sends the error back. If there is a success, moves on to the next phase, and the same thing happens again. So that way this moves on. And if it is a success and the software is released, then it goes for a deployment. In DevOps, deployment is a term which you will always encounter. Like people will say, whenever you work as a DevOps engineer, people will say mostly that, have you done the deployment? I have a deployment to do. Would you do it for me? So this word would always be encountered in your career. So what does that mean? Deployment means putting a code that is ready for release into the production environment or any environment where the code will run. For example, if I write a Android application, I write a APK file, I will deploy it in the Play Store. So that means it will be visible for other people to download that app and install it. Similarly, you are writing something for the iPhone, then you build the iOS file, and then you put it on the Apple Store. Then people can view that app and install it on their phones and iPads and so on. So that's how it happens. Similarly, if it is a website, you have to deploy it on some server on the cloud or some on-premise server. So that is how this deployment thing happens. So deployment means putting the code into the live environment where it would be visible to the end user. So that process is called the deployment. So when we do a deployment, we essentially automate the process of doing the deployment. And once the deployment is successful, again, it gives a feedback to the stakeholders. And then comes the monitoring stage. As soon as the software is deployed, there are certain scripts and other softwares which start monitoring that piece of software, whether it is working fine or not, whether it ran for 5 minutes and then got killed, whether it is giving an error after being deployed. So all that thing is getting monitored. And even things like number of users using that particular software at that point of time. For example, if I create a application and put it on Play Store and 10 people are using it right now, I would be monitoring that 10 people are using my app, and what I would not be able to see what they are seeing. That would be a security breach, but I would be able to monitor from a software point of view, like how many users have used this app, and what was the memory CPU settings, what is the performance of the app, whether it was fast or slow, how it was behaving under different conditions, and so on. So that part is monitored, not the data part, like what the user is doing. So that would be not monitoring, that would be spying. So here in DevOps, what we do, we just monitor the software and its and the way it works. And then once the monitoring, all these are continuous activities. Like once you deploy the software, the monitoring keeps on going until that software is live. It doesn't, the monitoring thing never ends. Once the software is offline, then the monitoring would stop. And then we have some offline feedback loop that is called the customer feedback. So once the software is live, you're monitoring it, everything is fine. DevOps also takes in the feedback given by the customers through various channels. So DevOps takes care of the ticketing systems as well. Like there are different softwares like Jira, or there's a software last time we had discussed called ServiceNow. And there are some open source ticketing systems as well called OS Ticket and so on. I'll demonstrate some of them for you down the line. So these are certain ticketing systems which are built and made available to the end users. So whenever they find an error, they can give screenshots, or they can just mention what problems were seen while operating the software, and taking that feedback. And again, that would be automated. Like once that user puts in his ticket, it would be triggering mails to different stakeholders, and they would be replying him and putting the suggestions into use, and fixing the problems and informing him back. So that is also a stage of the DevOps deployment process. And based on the feedback and the errors that came in from the test reports and the monitoring, the performance reviews and all, based on that, the business people, like the decision makers, again make decisions on what should be the future of the software. So that is how DevOps helps the entire organization. So in this step, what happens, like for example, you built a chatting app like WhatsApp, and that chat app started being famous, but it did not have a feature of uploading, say, videos. Initially it was just a text only chat, and you can send pictures. So then based on the feedback from different levels and the monitoring outcome that you're doing good, lots of traffic is coming in, but people are not able to share videos. So the business might have taken a decision to add this feature, and so on. So new features come in. For example, now if WhatsApp sees that well, people are moving into Zoom for meetings, I already had a video calling feature, why they are not using it? Because here you can have so many people at a time, you have a recording feature and so on, so which is not available in the other app. So then the business decision makers define or redefine whether that feature should be added, and then it goes into the DevOps continuous feedback loop, and new development starts and moves on like that in a circular fashion. So that is how this entire cycle happens, and we are the people who will make this happen, and who would automate it, and who would try to see that there are minimal errors. So how do we do that? That brings us to the practices. So what are the practices we do? So first of it is we do continuous integration in DevOps. Why I included this slide, I normally do not prefer much of I mean uh, theory things, because that never helps in real world, only for the interviews. But that I just wanted to have a little bit of definitions, like, so that you can speak about these things. These are the main concepts of the DevOps. So people ask in interviews or in discussions, like, okay, you are talking about CI CD pipeline, what is CI, what is CD? This is very common. So continuous integration is the process where the codes is integrated. These are definitions which help you to discuss with people about DevOps, and helps you in interviews. So you just understand the concept. No need to, I mean, mug this up and tell people. When someone asks you about continuous integration, you can say, like, in DevOps, everything is automated. That's the main principle. So whenever a code is being written, and you want it to build it into a end product like a software application, so that process involves many stages, like teach people. So, okay, coming back to these definitions. So whenever someone asks you, you have to know the entire stage that goes on in building that software, from raw code to the end product. For example, as we were talking, let's keep on having the same example so that it remains consistent. We have a shopping website and an app. For example, you have an Amazon app in your mobiles, and you have a Amazon.com website that opens up in browsers. So these softwares would have been written as code, and then they moved on to be stored in a certain repository in that company. And then people pulled that code from the repository, built it, tested it, and released it. And finally, it ended up in our laptops and mobile phones and everywhere, and we start using them. So this process is the process of the entire software deployment. Now, continuous integration is the part where your code gets integrated into the main software. I mean, continuously. So how does that happen? As soon as you write your code and merge it into the repository, it triggers a chain reaction of steps, and periodically the builds happen, the tests happen, and releases happen, and it moves on to apply it. You might have seen every other day we get alerts on our mobiles like software version this needs an upgrade. Do you want to do it now? Yes. Then it will upgrade the software. What does that mean? This continuous integration and deployment pipeline is going on. That guy might have built a new version, pushed it into the repo, it passed the test cases, got built, got released, monitoring was done, and it gave us an alert that you want to upgrade it. If I say yes, then it gets upgraded, then I see a new feature in that application. So that's how it moves on. It ends at the user. Like the user will have it on his device, and then the loop ends. Then the user gives a feedback that this is not working, or this one earlier one was better. Then they might incorporate in the future versions, and again it goes back cyclically. So integration is that part where the code gets shared into the repository and it triggers the deployment process. Now delivery is that part where the code is already built and tested, and it is ready to be deployed in the end user systems. Like the website is ready, and the user, if he refreshes the browser, will be able to see it. So that process from building to sending it to that user's browser or his mobile, that entire process is called the delivery process. So since it is continuous in DevOps, there is nothing like which stops. As soon as you release it, it will get deployed till the end, because everything was is automated. So it would be only stopping after the deployment is done. And you might be thinking, so what happens if it fails? So if it fails at a certain stage, it doesn't even move on to the user. So the user doesn't even know that Amazon app is failing 100 times before it reached me. So whenever you see something has reached you, that means it has passed every other stage. So it would not fail in your device. But even if it does, we have issues like that as well. You might have seen you installed the app, but that never opened. Like whenever you open, it crashes. So then you just don't do anything, or either there is a pop-up that your app has crashed. Do you want to provide a feedback? We will collect your data and send it to the company. If you say yes, then that data is collected from your system and sent back for the people to review. And in the next release, you see that you have updated the app and it's working again. So that's how issues get solved, and companies move on to the next version and so on with their product. So that is the delivery part. So you can just go through these definitions. I'm not going them line by line because I don't believe in just reading out and you remembering those things. So next is the testing phase. Again, we had discussed it. It is a continuous testing. As soon as the code lands in the testing phase, there would be some test cases which continuously trigger off and test those cases. Like there could be many test cases in a software. So whenever a coder starts writing code, At the same time, in a QA team, a tester would be writing. First, he would imagine like what are the different things that can be done in this software. So let me write those scenarios. So they will just write out scenarios that I have a website for shopping. So I will first log in. So that is a feature, that is a scenario. I log in with the wrong password, I will see an error. That is a scenario. I log in with the right password, I move on to the next screen where I see the products. When I click on a product, I see a product detail page. Then when I put it on, I mean, click on the select product, it moves on to the cart page, and so on. Like when you just imagine a software, you will be seeing different scenarios, and you can write out those scenarios, then write the test cases for those scenarios. What are the pass and what are the fails? Like for example, if you select the product and you do not go to the product detail page where you see the big picture of that product, the price and reviews and so on, then that means that process is failing there. If you go there but do not see a certain feature there, that means something is failing partially there. So that is how the testing phase happens. And because it becomes very slow if it is done in a normal fashion, well, like people used to do it earlier manually. So then it would take months to do a very good testing of an application. So writing test cases and doing a continuous testing helps to uh, make it more efficient and do it in a matter of few minutes. Like when we release softwares, I have seen it would take about 5 minutes at most to run an entire smoke test. So yeah, another thing, I told you, like just go through different testing methodologies, different SDLC patterns. Like for now, as I said, where a smoke test is something where you just test the overall things and see whether there are certain errors or not. Like you don't go into very, I mean, detail, but you just check. Then there is some testing called regression testing. There you, what you do, say for example some new feature is there, you test the new feature, but you also test all the features that were released earlier to this feature. Why that is done? You want to ensure that due to this release, something that had been released earlier is breaking or not. Okay, so this happens. Like for example, you had that shopping website that was working fine. Now you added a new feature of for example, what could it be, like say you add a new feature that the when you buy a product, it will give you an option of choosing if you want the same day delivery or you want it on a normal delivery, which might take a few days. So this was a new feature that came in. Earlier it was a normal delivery, slow delivery, but there is a feature that if you sign in as a prime member, then you get a delivery in a few hours. So this is a new feature. But as soon as this was introduced, some other thing that was working broke. This happens in software because a new logic is introduced and that guy might have done some mistake, and some totally unrelated thing in the program is not working anymore. So no one has seen that because everyone is concentrating on this new feature. So then what happens? The new thing starts working and some old thing that was already working last time in the last version stops working. So these kind of regression test cases try to fix these issues. They check everything that was already there and they check the new thing. But these kind of test cases take more time. So it depends whether it is a major release, then you do a regression test because something big is going out. So there could be lots of things breaking. If that is a small release, like for example you are just changing the theme of the website or you are just changing some small logic. For example, earlier the username could be of 15 letters, now it became 12 letters. So these kind of small changes, then you don't need to change everything because you just change a number in the code to not allow usernames bigger than 12. Earlier it was 15. So here you don't have any risk of breaking other things. So in those, you you can do a unit test. Unit test means just checking the one piece of feature that was introduced instead of checking all the features in the software. So that is how it works in the continuous testing phase. Depending upon the intensity of the tests, uh, it defines how much time that will take. When you do a regression test of a very big software, it might take a few hours as well, so that you are sure that every feature was passed. Even when you are doing it, uh, I mean, automatically, it could take hours. But uh, just imagine then if it was being done manually in those times, how much time it takes for the testing. It could go into months, but nowadays it gets over in hours. And then we also manage the release management phase. This we'll cover in one of the sessions, where we understand how I told you about semantic versioning, how that once a software is ready for release, we stamp it with a version number that would have a major number, a minor number, and a patch. So that would be, say, version 1.0.2. So first one is the major, minor, and patch version numbers. So that process and automating that process is called the building and releasing management process. So build is the process where you build that binary. Release is the process where you release that binary with tags. So tag is that number, version number. And then you move on to monitoring. Once the release is done, moves on to the user's machine, then you would start monitoring that application. We discussed this, and based on the monitoring, you see the app is not efficient, or if it is very efficient, then the last release. We have seen apps when you really install that app in your laptop, or once you started deploying it on your mobile phones, you see that uh, your phone has slowed down. So that means the monitoring metrics would send that data to the developers that this app is eating up more resources. So it has to be optimized. There should be some code that is not optimized, so it uses more memory, or if it requires a certain kind of device to run. So that's how they decide. Like, for example, sometimes we see this software cannot run on Android 5. It would run on the latest of Android, or it cannot run on systems below 2 GB RAM or whatever. So those things are estimated using the data from the monitoring phase. So everything in DevOps is actually, this is also something which you can talk with, you can tell people, like when people ask like, how does DevOps benefit me? Apart from that, everything becomes fast, automated and all. This is also another feature. In DevOps, every phase is based on a certain metric. Like, for example, we get data. So every phase we talk on data. We do not just say like that. Like you do not, in DevOps, you do not just say that increase the RAM, it will be faster. No, you do not say anything baseless. Everything you say is based on a data, that because last time in the deployment I saw the logs where the memory limit was continuously being breached, and there was the application slowing down, the page load time was this and this. So that's why I came to a conclusion that it needs more memory, or the code needs to be optimized, and so on. So DevOps helps you to optimize your product, because one cannot blindly just say if someone wrote a piece of code that is the most efficient piece of code, because everything has to be reworked again and again until it becomes very, very optimized. That's why you will see some apps are not very good, they do not load, and some apps are very fast, some websites are slow, some are fast. So it lies on how it was built. It lies on the merit of those developers who built it, or whether they built it in a correct way or not. So DevOps is that policeman who would catch all this and get it reported, so that the team, so it's not like we are against the developers, so we are catching their problems and giving it to them. No, we are a part of the team members who is like a whistleblower for each stage. So who alerts people that something is going wrong, something is failing, how could we do it better, and so on. So that's why DevOps is in demand, because you help optimize that software. As optimized it, I mean, the more the optimization happens, the more user experience will be good, and that company will become popular, because lesser the errors. Say for example, if you get a lot of errors in WhatsApp, uh, every other time it fails or crashes, would it have become this popular? Because it was convenient, easy to use, fast and all, that's why that is popular. There were many other apps as well doing the same things, but they never became popular. So it all depends upon how optimized it is. So DevOps practice is I mean, these practices help with that optimization. Then comes the infrastructure automation part. Yeah, this is very important, and this wasn't discussed in the last session, and we never touched this part till now. Now, just imagine your software is ready, and forget about your apps. Like when we are talking about infrastructure automation, we are just talking about websites, because apps do not need any infrastructure that has to be maintained by the company here. Like for example, if I give you a APK file, you will run it on your own mobile phone. If that phone is not very efficient, so you will have to upgrade your phone, so and so on. But the infrastructure that is on the server side, like for websites and even for apps, you have certain server side infrastructure. So we are talking about that automation. So for example, I have a website and I have millions of customers this shopping website has, and I want to deploy it somewhere. So I will need a cluster of servers. Last time I told you, like we will, for example, you have 100 servers, web servers where your app is working. For example, a search engine like Google would not be operating from one server, right? Because millions of people, billions of people are logging in at the same time to that search engine. So there should be millions of servers behind the scenes working together to keep that website up. So you do not even see whether it is down. Even if there would be servers dying, like getting killed, going down, and so on, because it is not possible that all the servers have been running since the time Google became live. So many servers would have phased out, would have been taken down, new servers would have been added, but we never see those things happening. We always click on that website and it pops up. So how does that work? How do they maintain millions of servers? Would they have a million people maintaining each server and checking its health all the time, fixing things if it goes wrong? No. So how does that work? Your infrastructure is automated. For that, DevOps has certain tools. We write scripts to build the servers from scratch. Like for example, you need Linux to be installed. So you would write scripts that would build a server, install Linux, create users, install the softwares that is required in that particular piece of server, and deploy those softwares and make it live. So, and join it to the cluster that was already there. And then you can remove some other faulty machine that was there. So that's how it works. Like everything is automated, and there are certain tools like you have, if you're doing it on cloud, there is a tool called Cloud Formation in AWS that allows you to write infrastructure as code and then deploy it. Like you write things where you write a program where you define which flavor of Linux you want to use. You want to use Ubuntu or CentOS or Red Hat. There are various flavors of Linux. So you define that. You define how much RAM will be there in that server memory. Say you say 8 GB. Then you define how much CPU processing power will be there, how much network will be there, what is the IP address of that system so that it is available on the network, and so on. You define everything in that program, and you say how many instances of that server you want. You want 10 servers, you define that I want to install all these things, and I want 10 instances of the server on this cloud. So when you run that code, it deploys those 10 servers. So this automation uh, is also is done for infrastructure. So you use tools like Terraform or CloudFormation to do that. So we will cover that as well. So these are the various practices in DevOps. Building the infrastructure. Last time even we were discussing how do we build the environments. So a part of that is this. You build the environment using some scripts where you automate building the servers, then you automate installing the softwares, you automate the entire infrastructure automation. Okay, so I mean, building the entire infrastructure, you automate those using these tools. So this is also important phase. So when you are going in a CI/CD pipeline, when you are going to do the delivery of a website, before you deploy that software on a website, for example, I have code ready and I built that code into that artifact. Artifact is the jar file or the exe file which is ready to be installed. Now I need a machine to install this, right? For example, I ask you to install a software and I give you that software. For example, I asked you to install Zoom. So you downloaded zoom.exe or whatever operating system you're using. Based on that, you downloaded the file, binary file. So that artifact has to be deployed. So you need to have a laptop or a desktop where you will deploy that software. You cannot just download and do nothing. So it's the same here. When you are having the code of a shopping site, now you need a server where a web server would be running to serve that app. So how do you get that server? If you start building that server manually, you go to the dashboard on cloud and start clicking here and there, defining things and then build it. That takes time. It doesn't happen like that in a fast moving company. So they do not have time for someone to go and build this, create the server, then someone else will log into the server using a password and deploy. That's not how DevOps is. So with DevOps, what we do, we write a code and that code is run to build that server, and then we put that software in that server automatically using our pipelines. So that is why these are the practices, and that is why these practices are in demand. So let's move on to the next thing. This is also about those practices. Now this has been summarized because the previous slide has so many definitions. Now what are the essentials we need to learn in order to implement these practices? Because in the end, I told you DevOps is easy. It is not that overwhelming like it might seem now. It is easy. So I tried to simplify it by only mentioning the things that you would know to learn. Then you can call yourself a DevOps engineer because you know these practices. So 4 things you have to know. One is infrastructure as code. So we will learn this practice of DevOps, like how you can build the infrastructure as code. This is what we were discussing a few seconds ago, like how to build that server or that web server to make it ready for the code to be deployable there. So learning the automation of that process, how to get the configurations right on that server. For example, you have a web server and you want that server to accommodate 1000 active users. You want that server to listen on a particular port number and so on. So you can define all that in your code and you build that server uh, accordingly. So learning infrastructure as a code is a DevOps practice that will help you. And then you will learn how to do the CI and CD pipelines, continuous integration and delivery. We have discussed this many times. So it's just the process of building your code and delivering it on this infrastructure. Okay. So you have to know how to automate these parts. And then this is something very new, but many companies have started adopting this practice. So I thought of including this one because that will help. This trend will remain in the next at least 5 years before something else comes up. So what is this? This is about microservices. Nowadays, when software applications are built, uh, they are broken down into smaller softwares which can do only one functionality. Let me explain with an example. Again, with the same example of a shopping website. For example, you have a Amazon.com, which is live, and it has various features. Like it would have one feature where the user logs in. There is another feature where the user chooses something. There's another feature where the user makes the payment. For example, you have these three features in that website. So you can build the entire piece of software as one big block. Like you write all the code, and all that works together, and if something goes down, then the entire software website will go down. So that kind of architecture is called the monolithic architecture. For example, you have written your code in such a way that all works, everything works, or nothing works. Like if something is not working, then the website will not open at all. It will say server unavailable, 500 internal server error. You might have seen these kind of error codes in the browsers. So what does that mean? Some component is broken, and due to that the entire website is not working. So companies nowadays are moving away from this architecture. They don't want a small failure to be the reason for a catastrophe. So what does that mean? For example, some login feature is not working in Amazon website. That should not be responsible for the entire website to be not working. It's fine that some products are not loading, some persons are not able to log in, because these things can be addressed if the errors are staggered. Like some people are facing errors, some are not. So this is better than all people facing errors. Okay, so in order to achieve that, these softwares are broken into microservices. Like each feature is bundled into a microservice, and all the microservices are independent of each other. That's the architecture. We will do this, like we will deploy a simple microservice based architecture so that you know it, because this is a vast thing in itself. But developers would be more concerned with how to build it. Being deployers, we don't have to learn how to build that service, because we are not going to write that program for a microservice. We have to know what it is, we have to know how to automate it, how to build it, because that's our area of concern. Like we have to know how microservices work, how to deploy them, how to deploy multiple microservices in a way that they work together. And people think that it is one particular piece of software, but inside it is many things. So that is what microservice is. Like you have certain features bundled into a software which is independent from the other. Like the login functionality is independent of the product functionality, which shows the products on the page. The payment functionality is different from the others. So each one is independent. If a certain feature goes down, that particular feature is down, but the website and the other parts are working. So that's how it is done in microservices. You do not keep a dependency on the entire thing, so that if something goes down, the other parts of the website are working. Google does this a lot, and like big websites, Twitter, and these shopping applications and all, which have huge traffic, they follow the microservice practices. And streaming providers, uh, so Netflix and all these guys, they use microservices. So sometimes you will see some feature is missing or not working today, tomorrow it starts working, but the entire site was up. It never showed like site cannot be displayed or some error. You never see the errors anymore. But you might have seen smaller websites, the entire site is down, sometimes it comes back again. Mostly, if you remember the websites we used to check our school results, that website would go down on the day when you when it's the results day. So that's a monolith app. So it would have a piece of code. If you get more traffic, something slows down and the entire site goes down. Had it been a microservice, I mean, some of it would have worked, and they could have scaled up that part in order to sustain the traffic. Like scaling up means, like for example, you see the login is going down because many people are trying to log in at that time. So you can make 100 instances of that login feature, and once the users are logged in, you don't need that anymore. You can scale it down again. So that's how dynamically these things are deployed. That's how big websites can handle huge traffic without downtimes. Next. Okay, that's all about the theory and the concepts that we discussed, like what are the practices and all. You can rewind your video later on when I send you the recordings and go through them, because I want these concepts to be in your mind, I mean ingrained in your memory, so that you can explain and speak about DevOps. The first video about the introductory things, and these few slides, this talks about like what DevOps does, and how it is practiced, what are the important things that are done in course of DevOps journey, and so on. From now onwards, whatever we will do would be mostly about these tools and how to implement it, and it would be more hands-on and more towards the application of DevOps, and not much about theory and talk. It would be more technical from now on. So in order to start working on this thing, you have to have some softwares installed in your laptops or desktops, and then only you will be able to do it comfortably. Like first, you will need some text editors. So I use a text editor called Atom. You can use that as well. If you are using a Linux or a Mac, then it comes with a command line interface like this screen, terminal. So here I can write commands, like I display the files or whatever, anything I do, I can run the commands here directly. But in Windows, you have a command line, but that is a DOS command line or a PowerShell. So that is different. I mean, that is different area altogether, because that is only for Windows systems. That is written in C sharp. So that is a different line of programming altogether, because we are concerned more about Linux systems. So when you would be trying to connect to a Linux system from a Windows system using a shell, like a command line terminal, then you will need a software called Putty. It's like Putty. I don't need that because I already have a iTerm in Windows, Linux, and this you have a terminal called iTerm. But in Windows, you will need this software. So go there and download it. Then is the hypervisor. Yeah, this is about installing the Linux images. Images means the CD. You remember, like for Linux, we have a CD image burned in, and we take it and install it on a system. But here we are installing it virtually. So in order to create a virtual machine in your Windows system, so that means you are using a hypervisor. Hypervisor is a software where you install an operating system inside another operating system. So you have a Windows system already, and you put Linux on the top of it. So actually your system is Windows, but inside it you are running another Linux and then logging into that Linux server. So this part I'll try to show you today itself. So this one you can try it on your own. Multiple browsers, nothing to explain here. While doing DevOps, we need to log into the same website in multiple sessions and so on. So we might need multiple browsers. Like you have to have Chrome, you have to have other browsers also, because some test cases and all run in. You have to just ensure that it is working in the other browser or not. So it helps to have multiple browsers. So have at least two of them, Firefox, Chrome. Then API clients. This also helps to test certain API endpoints. So there is a software called Postman. So you can just search for that one. Postman API, and then you download it and install it. This is Git clients. This one you do it in priority. So in Linux, we just install a Git client. Like there are different commands, yum install git. So it installs a Git client. This command works when it is a CentOS Linux, Red Hat Linux. If it is a Ubuntu Linux, this command installs Git. If it is a Windows system, or if it is a Mac, then brew install git, and so on. So how did I know this? Because I have been using this. How will you know this? When you are stuck with installing, you will Google it. It's as simple like how to install git in Linux, how to install git in Mac. No one needs to remember all this. I never recommend remembering and asking questions. This is foolishness to expect a person to know everything. Once you keep using, you will automatically know. So no worries about that. And in Windows, how will you install a Git client? Windows has some Git clients available in GUI form as well, graphical interface. So one of them is Tortoise Git. Okay, let me just, you can just search like this. I'm not very confident with Windows, so I just all right, so here Windows, you can just search any Windows Git client and try to install it. Like this one looks good, Git SCM. So you can install it. It will have a graphical interface like this. Like our aim is to get the work done. We want to connect to a Git repository and do our stuff. So you can install this. You can also install a client called this one. It should be available for Windows, Git Kraken. This one I have used and I found it good. Let's search. Why am I writing and searching these things? So that it gets recorded in the video. So you can do this. Yeah, it's there for Windows. So you can install this one. It will have and go, it asks for a price, but you will be a single user. So it's free. Database clients. This thing is towards the end of this this course, so you can do it. Like there are lots of clients like SQL Pro, there is a MySQL Workbench also. So these are clients which are used to connect to databases. Like there is a database, you want to go and see what data is in there. So in those cases you will need this client. So one is MySQL Workbench, this software. Go there, it's Oracle product, so it's free. So you go there and download and install this one. IM clients, this is instant messengers. This is important in DevOps. This you have already done. It's the Slack. That's why I told you to install Slack. Most companies will have instant messengers like Slack, because Slack has APIs. Like this software has APIs using which you can post your feedback from each step of deployment already. Next, we will have to install Docker. So this one, no need to do it now. When we arrive at that, because this is a entire, session in itself. So just like installing hypervisor, this thing will take time. Like there are lots of things. So we will do it separately when we cover Docker. And if you are doing something on the cloud, like for example, last time we were discussing that we will if we are doing something on Amazon cloud, we might need a AWS CLI and so on. So these are those clients. So nothing to do right now. When we deploy something on a cloud, then we'll try this thing out. So I'll show you at that time. But yeah, we will be only focusing mostly on the DevOps parts and not entirely into that cloud, because that cloud command line will have lots of other capabilities as well. That is a part of cloud infrastructure, so that is different from what we are doing, but we will learn like how to use them. So when that this thing comes, then I'll let you know how to install this and how to use this. But for now we'll need the rest of the things. All right, so now let's move on to this hypervisors thing. So that will help us to install Linux on your Windows systems for now, because you're not using a Windows based system, and it will allow you to do your labs on those Linux systems going ahead, because there would be many softwares that we would be installing. So we can directly install it on that Linux system on your own laptop. And another thing, if you have a cloud account, or if you create a cloud account for yourself, at some point you might need a AWS account for trying, then you can create one. That would help you, but not now, later on, like towards the mid of the course you can create one. They give you a free trial. Like, I mean, most of the clouds will allow you to create small servers uh, and give it for free for 1 year, and you don't have to keep it running, like when you do something and then destroy that instance, so they would not charge you. So, and after 1 year you would be, I mean, if you are into DevOps, you would be working somewhere, and then you can use the company's accounts to do your stuff. So while in the learning phase you can do it that way. In the free account you can try out the cloud servers also, then you would not need the virtual machines. But if you want to do it completely on your own system, then you have to do the hands-on. So what do we do in the hands-on? Okay, let me download. I mean, I have already downloaded, because it will take a lot of time to download, but I'll show you what I downloaded. So I was talking about hypervisors. So when you're doing it on Windows, you can install VirtualBox. There is another software called VMware. You can do that as well. But again, that VMware has a licensing story to it. It's not entirely open source. So then better to go with the open source one. Oracle VirtualBox, this one. So you can download this. Whatever is the latest version, download it. And when I downloaded, because mine was a Mac, it automatically detected and it downloaded a Mac version. So this is the software. Okay. Okay, coming here reminds me of this. I'll send you this PDF. This is not, I mean, this is not my content. This is just, it was available on the internet, because last time you were asking if you can brush up on your Linux. So this book will get into the VirtualBox. Let me just tell you this one. This book has some basic concepts on Linux. No need to read the entire book. It will take a year to complete that. So better just go through the introduction when you have time. No need to read kernels and package management. Just go through the introduction, the commands, bit of this chapter 4, process management, introduction, and a bit till the file systems when you have time. What you I mean, what I'm suggesting is to do this parallelly while you are doing this, so that at least you know things, what is going on. It's not like I will be running commands and you just know that this is the command to do this. You have to have some background on Linux also. So that is your self improvement thing. If it doesn't happen and you find it a difficult beast to tackle, because Linux is not very easy, I'm telling you, because we have been using it for many years, it has become a second nature. But for those who have, I mean, used it to a minimal level, they would find it overwhelming. So then we can think of doing additional courses and all, but that comes only when you don't feel that you can do it alone. So do this disk management part a bit to understand what disks are, how partitions are done in Linux, because these things you have done in Windows also. Just try to match your understanding of Windows with that. In Windows, you have seen C drives, D drives, E drives. Similarly, in Linux, there would be partitions. So these kind of, like, there would be analogies. User management, how in Linux you create users, how you give them permissions, and so on. So this one. And scheduling tasks, this one is also required. Like, you schedule the tasks that run on certain times. So just go through this book. For no need to go through security and advanced things, but this book will give you a general idea on how Linux works. Then I will take one session at least, I mean outside this DevOps, just to make you understand how Linux servers operate. Like, there are various servers. If you want to build a website, you build a Apache web server. If you want to build a file sharing server, you build a Samba server. So there are many such servers in Linux. So I will just give you the important ones, how to build the FTP servers and so on. But that is the entire different course altogether. But I'll take an extra session for this just to make it clear, because otherwise that might become a blocker for this course. You have to know how to deploy servers in order to do the CD, continuous deployment thing. So go through this one. Now coming back, how to install that Linux so that you can follow that. So first, for the hypervisor in Windows, it is very straightforward. You just click it and it gets installed. In Mac, it's also similar when I click it, but this wizard that comes up is different. So I don't want to do this and confuse you. In Windows, it will give you a window where it will ask you the same old thing, next, next, and finish. So in Windows, you are covered. So here in Mac, we pull this one and put it inside this applications. And then we go into applications and double click that. So in Mac also it's simple, and then the wizard comes up. But since I have installed it already, that wizard did not come. So it directly takes me to the VirtualBox Manager, this dashboard. But in Windows, initially a wizard will come. No need to do anything, just take it default. Like, first it will ask you which drive or where you want to install. If it is already the default C drive, you have space, do it. Otherwise you make a different drive and do it. And then just move on with the default settings. If something is wrong, I will make you change the settings later on. But I mean, out of the box, it should work. So once it is installed, you will see this. Okay, should I stop? Any questions? All right. So let me move ahead. So when you install it, you get to see this. But now we have only started. So hypervisor is ready, but we don't know how to install the Linux application here. So next thing is to get the Linux software. So in Linux, you have lots of flavors. If you want to install CentOS, this is an open source version of Red Hat Linux. So you just search CentOS download, and you will get a download link, and you can download it. This is a very big file, around 3 gigs or 4 gigs, 3.8 gigs or something. So I would not suggest to download this at this point. That it contains a graphical as well as non-graphical. You can do it also, it doesn't matter. Only thing is, your laptop should have good memory. Otherwise, when you do this thing, I mean, having a virtual box inside, because you are having Windows 1 operating system, and then you are having a virtual box inside it, Linux. So you need to have a lot of resources. Otherwise, your system will slow down. So at least 8 gigs of RAM should be good enough. Mine is 8 gigs and it's working fine. So do that. If you don't have that much, I mean, your laptop doesn't have that much memory, try it. If it fails, we have the plan B of doing it on the Amazon cloud. So you can do that there as well, but try it. So CentOS, you can download this and do it, but why I'm not suggesting this one now, because it's a large size, and there are lighter weight Linux also and more popular in the industry. Red Hat you can do, but don't do it, because Red Hat Linux is a paid version of Linux. So you should not, I mean, you can install it for free, but inside it, when you deploy certain softwares, you will see some limitations. Like it, when you update a software, it will ask you for a license and so on. So you will get pissed off with these alerts. So let's go for open source of Linux version, and a very popular, so that is Ubuntu. Most companies, you will find this Ubuntu version of Linux. And there are two kinds of Linux version for most of these flavors. In Linux, the type of the Linux is called a flavor, and it has a GUI model, and it has a CLI also. So mostly the server editions are CLIs, command line only. So in those Linux, you don't see a graphical interface. Initially you will hate it, but for those who have already used it, they find it, it's just something you have to do. So Ubuntu server download, you can check, and you will see the download links, and go into that and download it. Okay, so I have downloaded this particular server. So you can see in my downloads, when I download this, I get this ISO. So ISO is the image where the Linux is present. If you click it, nothing happens. Like it's ISO file, it's a binary, so you cannot see it until it is installed in a hypervisor. So we have our hypervisor ready. So here you click on okay, these things are typical to the Mac. Here permissions are there and all, but in Windows you won't see these kind of stuff. It is asking for different permissions. Okay, here you choose your software and so on. Okay, that's why it is. New allows you to create a new operating system. You can have multiple things on one particular VirtualBox manager. So that's why here multiple things are there. Let me increase size. So let me show you how to install Ubuntu or any Linux. So let me name my Linux server. Why I say 01? Because in future we will be working with multiple servers. So let's tag it, because when we will be working with 3-4 servers at a time, so at that point we should have a proper nomenclature. So Linux server 01. So here you can see you can choose the operating system. Since we are installing Linux, we choose Linux. So here also you see a Windows. What does that mean? You can install a Windows inside Windows. You can install Mac inside Windows, and so on. So it's a very good software. So Linux, and then here you can choose 64-bit. Most of the laptops nowadays are 64-bit, so you can safely choose that. And if you are sure of which version of the Linux you are using, you can even define that. So we know that we are installing Ubuntu 64-bit, so we can choose it. If you are installing, if you do not know, then you can straight away select Linux. But since we know what Linux we are installing, we can choose Ubuntu. Then continue. Then it asks you how much memory would be allocated to that Linux server. If you have a good amount of RAM, you can increase this. Default one was 1 GB. Say I think I have memory in this system, so I'm making it 2 gigs. So then continue. Create a virtual disk now. leave it at that. What is this? This is the hard disk that will be created inside that Linux server. So Linux server will have some hard disk. So it will take some space from your Windows system and create that hard disk, which is 10 gigs in size. So I think 10 gigs will be enough for us. You can even modify it later to increase the space and so on. So let it be at 10 and then create it. Now you might be thinking, if you want to modify it now, you want to make it 20 gigs, how do you do that? So this option is not there here. You can go back and select the export mode. So there it gives you the opportunity to create, like when you move on in this mode, again we have to start from scratch. Linux server 01, Linux is selected, Ubuntu 64-bit, and create a hard disk now. Oh, sorry, this one should be 2048. Okay. This one was already there because last time we clicked that there. So I can do one thing, users. This thing will not happen to you because I have done it earlier. So some old folder was still there. So I am going to delete that folder and try it. What was that? Users. And in Linux, the paths are case sensitive. So you have to write it as it is there. Okay, the V was in uppercase. So this is it. And if you're deleting something, then you need some super user permissions. This thing is not needed for you, like you just ignore it. This is happening only because I had VirtualBox earlier, so I am trying to create it again, so that's why it was showing this error. So now it allows me to define the size. Okay, say I want to make it 15 gigs, I can make it 15 gigs. And rest keep it at the default settings. These are the image types and all. These are needed to make it interoperable between different hypervisors. For example, if someone else is using a VMware, he can take your hard disk and attach it in their system and so on. So we don't need that. Like, this is not what we are doing now. So create. So it shows that one Linux server is ready. Now this server means the hardware is ready, not the software. If I run this, it will not boot. Like, imagine you bought a new computer, it does not have Windows installed in it. Then what will happen? If you switch on, it will show a black screen and say no disk found, or no, unable to boot error, something like that. So if you start it, you see, select the optical disk. It says that we don't have a software, so select the software. So it does not start. So here you will choose the disk image that you had downloaded. It's not letting me browse. Okay, so I browsed to the location where I had downloaded the disk, and then I choose it, and then I start it. So you see this little Linux system is booting up. I think this can be made bigger. It's too small to. Okay, when you do it on a real laptop, it will, it will show up bigger. But here, maybe I'm not adjusting the resolution well, so it's not coming up bigger. Hope can you see this? I mean, it's very small. I'm sorry.
Yeah.
I'll fix that later on. I'm just showing you, like, once you choose that disk, it starts booting. We are doing nothing, and it gives you a wizard, and you don't have to click anything. Like, you have to now use the uh, keyboard to do your navigation. Okay, keyboard, and occasionally you have to use the mouse. And here something is important. Once I click this inside this black box, then what happens? My cursor will get captured inside the Linux system. That will not allow me to move into my Mac or Windows host. So this software outside is called the host. The one inside is called the uh, virtual machine. So host and the VM. So when the mouse is captured by the VM, you won't be able to go out. So there is an escape key here. So that would be defined. If you click here, you will see like the shortcuts. Control Alt Del will get you out of this. Okay, so that's how your installation will happen, and then after that you press Control Alt Del and come out of the Linux and back into the Windows. Once I click inside the Windows, then I will only Linux, then I only am able to do the Linux stuff. So now the first default choice is English. So I just press enter there. Sorry, I have to select this, press enter, press all the default options. Okay, it shows a IP address there, done, 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 and so on. There is a easier way to do this also, but I would like you to do this first, then I'll tell you the easier way, because this one you have to know in order to, I mean, just try to install it yourself and see whether you get to the end of the installer or not.
Okay.
Otherwise, there is another option of creating an image and sending it over. Like, for that, suppose you are not able to install the Linux, then I will install Linux in my system, and then I will export the image of that entire thing and give it to you. When you just click it, I mean, you will have to have VirtualBox installed in your machine, and then when you click my image, it will automatically import it into your, I mean, VirtualBox manager. Or you can use that other option. Sorry, let me just allow. You remember when I opened the manager, there was another option called add there. That is not here right now because I created a new one. So when you add that and select that image that I sent, you already have a running installation of a Linux system. So that is also another shortcut way of doing it. So you can try that later on, but I think you will be able to install it. It's all self-explanatory. Like, when you install, it will ask you a question, read it and do it. Otherwise, I'll also send you a link. There are lots of YouTube videos for installing a VirtualBox. So I'll send you one such link, not my video, but anything that is good. So you can see that and install it on a Windows system, because I am doing it on a different operating system. So these steps are not there in your thing. But yeah, you will see this layout, and I am using the tab key to do the navigation. I told you here the mouse will not work. So I use the tab to move from different places and click on the done. So it will be the same for you on Windows also. Use the tab. See, it has automatically detected that Windows hard disk and so on. So just I'm doing the default steps and using the tab and the arrow keys to move to the steps. So it is asking, do you want to continue? I am saying yes, continue, and so on. Then it is asking my name so that it will create a user. So let me name it DevOps, and server's name Linux server I'm sorry, this screen is very small, but this will not grow until the drivers are installed. So that's why it's small. So once the driver is installed, it will, I mean, there is a graphical driver. Once that gets installed, then you will see the correct size and resolution. So that will take a lot of time. So I didn't go into that. So for Windows, you won't see this kind of error. Like it won't be so small. If it happens, then you will have to do the initial installation the way I'm doing in a smaller screen. Once the installation is complete, it will detect the driver and it will be a normal size. Because now even if we are increasing the size of the window, this thing isn't growing. So we have to make do with this much. So I'm just filling up the form. It's asking me username, password, what server name you want to give, and so on. So and password also, let me use the same DevOps. Install SSH server. You have to say yes. Like if you want to install, choose something, press the space bar. Okay. So what did I tell you? You use the arrow keys to move here and there in a command line. You use the tab key to move here and there, up and down. I'm using the arrow keys now, going down, coming up, and so on. So you can use the arrow key or the tab, and when you want to mark something or unmark something, use the space bar. So I am choosing this, unchoosing this. So that's how the selection is done in command line. So I choose to install OpenSSH. I will tell you what that is when the time comes. And then here it's asking, there are some popular servers, would you like to install? No, we don't want to do anything now, because if I have a pre-installed server, then you would not see how the installation is being done. So we will do everything from scratch. Like we don't have anything in our server, so we'll do it when needed. So I'm moving ahead. So it has started installing. So nothing to do now, just get some popcorn and wait. It will install it. So after the installation, you will get that username and password prompt, and then you use the username and password to log into that server. And then begins the Linux commands and all that thing. So you get till this stage, and then we will take it from there. You just do the installation part. And if in case installation fails, just search. Meanwhile, okay, it is downloading some update. So I think what I did today is the latest version. So I think I won't need an update. So I'm canceling the update, because it will update for say some time, and then okay, that was fast. It updated it. So I will reboot now, and then we will see the new system. Ignore these failures. Like you don't have to worry about this one, because it was trying that virtual CD-ROM from where it installed and tried to reboot, but it could not stop that CD-ROM and so on. So you can directly kill this. Power of the machine. Because we have the system installed, we know next time we boot, the system will start up. Next, before starting this system, you have to do one tweak. In Windows also do this. Go to the boot order and uncheck the optical. This is the floppy, because now we have already installed from that ISO image, that is this optical drive. Like it imagines that ISO image to be the CD drive which has Linux. So you don't need that anymore. It's already installed now. We will boot from the hard disk. So keep the hard disk ticked, everything else not required. Okay. Now start. Normal start. Okay. this thing is happening only for the Mac. It is asking me some permissions, so I will do it. In Windows, it will not ask it this way. So in Mac, it is asking me to provide permission to VirtualBox. So I ticked and I allowed the permission. Okay. So here it is booting the Linux system. Again, I'll fix the resolution later. So now let it just boot. In Windows, I don't think this problem will occur. If it occurs, we'll figure it out, like what driver to install to fix the resolution here. But I don't think that would happen. Here it's the Linux. I mean, inside Mac, we are installing a Linux. So maybe some driver is not getting detected. So it's showing a small screen. Okay, now the server is getting booted for the first time. Booting means starting up. So we are just starting up the server. Once the boot process gets over and if everything is fine, then we will get a login prompt where we will be able to, have the username and password and log into the server. So this is it about, like, we will continue from there, like we log in and do the rest of the stuff from the session. When we do, like, next time even, we will discuss about, first we will move on with logging into this server. We will install Git and then we will start learning about the the version control system. So that will be the next thing which we are doing. So now this will take time and bring you to the login screen. So that is it you would do. And once you are done, right click and pause or stop the instance. Okay. When it is started, it will show a stop option also, or you can just click pause. So if you click pause, it will go into the pause state and then you can close down your VirtualBox. I'm just leaving it here because this will take time and get it installed, and then I'll stop my system. So no point of waiting till then. It will initiate this and get you to the login prompt. Once that is installed, we are good. If you face some issues there, then we'll try to, I'll send you that image, or you can, I'll send you a link to see that video and try doing that. But I think it's straightforward. Like, take an image of Linux, install the VirtualBox manager first, keep that image somewhere, click on new, then move on to through the wizard, choose that ISO file where you have downloaded it from your downloads folder, this one. And once the ISO is chosen, move through the wizard in the command line and then go to the end of it, and then you will be asked to reboot the server. Once you reboot, you have to uncheck the boot order and keep just the hard disk there, and then you will be able to see Linux starting to get initiated in your server. So that brings us to the end of the session. Keep learning, and thanks for your time.